Okay, we're going to look at calculating the angle between a line and a plane. So, an angle between the line EF and the plane ABCD is defined as the angle between EF and its projection onto the plane. Okay, so basically a projection is this dotted line down here, FG. It's like if you shone a light, red up here, okay, and the shadow that line would make on the plane would be there. So this is coming down perpendicular, and that is the projection. Okay, so really what we're trying to find is that angle in there. So for our purposes in this class, we're going to think about what it would be if we had a pyramid. Okay, so we've talked about pyramids in measurement, and so we're taking a small portion of a plane, and then of course we have lines that intersect. Okay, all of these edges. So the angle between an edge or a face and the base of a 3D shape. So that's what we're going to do right now. That for IB at this level, that's all that we need to learn about. If you do go on to Math 35, you're going to learn all about vectors and then calculate angles between lines and planes, between planes, all that kind of stuff. So that's if you're going into Math 35. But for this, our purposes, and if you continue to SL, this is what we need to do. Okay, so angle A, you can see there is the angle between a face of that pyramid and the base. Okay, and angle B is the angle between an edge. All right, so let's go to some calculating. So here's a pyramid. You can see the base is a rectangle, so it's a rectangular base pyramid. We're given the dimensions and we're given the vertical height, but not the edge distance or the slant height. So that's what we're first going to calculate. Find CB. So that's the edge there. I'm just going to make this thinner here. So really, that forms, so we know this is the center. If I draw a line out to the edge here, okay, then I have a 90 degree, but I don't know what this distance here is. Okay, and I don't know any of the angles. So what I could do is do a line here, which could extend out this way as well, but that forms a 90 degree triangle in the base. So really if we were looking from above, it would look something like this. Okay, and so this is D and this is B. So what are those distances? Well, think about the entire length here is 10. So we need half of that. This would be 5, okay? And then this entire width here is 8. So half of that, because this is the center, is going to be 4. Okay, so a little 4 in there. So if we can find this side, DB, then we can use Pythagorean theorem to find CB. Okay, so DB, I'll do it here. DB squared equals 4 squared plus 5 squared. So DB equals root 41. Okay, and then CB, so now we've got our triangle, we'll just put it up here. So this is DB. C. So now this is 6. Now we found DB is root 41. And we want to know what CB is. So it's a hypotenuse as well. Okay. We're keeping them as exact values until the end. Okay. Oops, I'm putting this in the wrong place. In any case, I'll move it in a sec. So this is 36. Remember, root of 41 squared is just 41. So that is 77. So CB equals root 77. Okay, we found CB is root 77. For part A, it says exact, so we're good there. Then it says find the angle between the edge CB, so that side that we just calculated, and the base of the pyramid, round to the nearest tenth. So remember, that's going to be this angle in here. Call it theta. So really, that's the angle. And now we know this is root 77. Now, saying that, we didn't really need to calculate CB. You were asked to do it just because we wanted you to realize that you have to do basically two separate triangles. But it's not required once you find root 41, right? Because now we can use, I would use tan. So tan of theta is 6 over root 41. Don't rationalize it. This isn't your answer. You want to take inverse tan, so get out your calculator and go make sure it's in degree mode. And then second tan, 6 divided by root of 41. Okay, and that's 43.1 degrees. Okay, so that's the angle between the edge and the base of the pyramid. Then we want to, really we're going to look at the angle between the face ABC and the base of the pyramid. There's two faces here, two different sized faces. So we're looking at this big one at the front. You could also look at this side one. They would be different. So just realize that. This, what we just calculated, is more of the question from above, or on the top of your sheet, the angle between a line and a plane, because that's a line. This is basically the angle between two planes, because this is just a part of another plane that's intersecting. So in a way, you're doing some work that you will learn in Math 35, but we'll kind of learn it in a different way, okay, using vectors. Okay, so find CM. So CM is this slant height. Oh, I guess I read the wrong triangle. So we're doing ABC, which is that side triangle there. So calculate that. So now, actually, maybe I'll do that in green. Okay, so now we're doing this. Okay, so our triangle for that then, so this is C, this is M, okay, this is D. We know this is 6, and we're trying to find this. This DM here, well, that's half of 10, so that's 5. So CM squared is 6 squared plus 5 squared. So that's 61. So CM equals root of 61. Okay. I guess these all are in inches, so in terms of those measurements, they're inches. Then find the angle between the face and the base of the pyramid, round to the nearest tenth. Well, you've just found a line there, right? So we now want to find this angle. Okay, and again, we didn't need CM. We were just calculating that, just a separate question. I would just use tan again of theta, we'll call this theta 2 because it's different from the first part, equals 6 over 5. So so theta equals tan inverse 6 over 5. Okay, 50.2. Okay, so that's a way of calculating angles between a face and a base, and a line, an edge and a base. That's it.